What do we mean by the science of statistics? Well, statistics is actually part of all the sciences. It's fundamental to the scientific method. Statistics is a way of taming uncertainty, of turning raw data into arguments that resolve profound questions. Now, words are also constructed into arguments, which can be used to cloud issues rather than to clarify them. And it's possible to manipulate data in a similar way. Numbers can also be used to confuse, overpower, or even trick us. But the science of statistics is there to teach us how to make honest, verifiable arguments from data. Statistics puts reason back in charge. It's our way of harnessing numbers, using them to help us make sense of the world. How exactly does statistics grapple with this rather imposing responsibility? Here's one way to picture it. Imagine the steps you might take to investigate some puzzle that intrigues you. First, you describe the situation, trying for a clear, compact, and concrete summary. Then you formulate more specific questions and set out to gather information precisely tailored to answer them. Finally, you draw conclusions from the information you've gathered and determine how certain those conclusions can be. These are exactly the ways real people use statistics to solve real problems. We usually start by pulling together existing data to get a description, a numerical picture of a situation.
Lightning, the beautiful and devastating caprice of nature. Our technology can't yet predict where lightning will strike, but we now know a lot about when lightning strikes thanks to research conducted by Raul Lopez.
In 1 year, we collected 750,000 flashes in just a limited area here in Colorado. So we were overwhelmed. I said, well, what do we do with it?
What Lopez did was to chart the data, making a column for each hour of the day. The picture that emerged was surprising. Lightning usually begins between 11 a.m. and noon. There's a happier future in store for children with certain kinds of growth deficiency, thanks to the development of synthetic hormones. How can we tell if a child like Sarah is growing normally? Her doctor makes a record of Sarah's height at frequent intervals. The chart creates a visual comparison between Sarah's growth rate and the broad pattern that describes most children her age.
Up to about age 2, her growth rate was close to normal. After that, her growth rate fell off rather strikingly, so she started to have absolute growth points below the normal range on the growth curve.
The doctor prescribed synthetic growth hormone treatment. It's no joy getting a shot, but Sarah is now expected to reach a normal adult height. Off the coast of Florida, statistics helped save the lives of these gentle creatures. These are manatees, vegetarian sea mammals who like to float just beneath the water's surface. That habit makes them the unwitting prey of powerboat propellers. Comparing the number of powerboat registrations with the frequency of manatee deaths, researchers found a clear relationship. As registrations increased, so did accidents that killed manatees. As a result, Florida created coastal sanctuaries where powerboats are off limits and the manatees can float freely.
Fly ball deep right field, headed for the seats. A home run for Pagliarulo.
Baseball is a game of statistics. Every pitch and every swing are logged, averaged, published, and pondered. Home runs can change the averages dramatically. And they also figure in some statistics that are especially important to the players. Compare the number of home runs a batter hits to his salary in hundreds of thousands of dollars. There's a subtle but interesting relationship which statistics describes as a positive correlation, symbolized by the letter R.
They understand the payoff is larger, and they're going up there trying to hit that long ball and make big bucks.
The second phase of statistics involves producing new and reliable data. This is the province of three familiar but often misunderstood words: samples, experiments, and probability.
This is a fishing boat, but these fishermen are trolling for data, not fish. They're measuring the damage done by pollution to the Chesapeake Bay.
You can't use monitoring data and trend lines or just regression lines to assess whether things are getting better or worse.
The backbreaking work of collecting new data follows a precise statistical plan. Random samples of mud are skimmed from the bay floor. Clams and worms living there are sifted out and brought to a lab for study. The health and abundance of these creatures can be translated into a sensitive index of water pollution. Studies like these help to spark new legislation aimed at cleaning up the Chesapeake. The work continues, producing new data at regular intervals in order to monitor the bay's recovery. Heart attacks kill 500,000 Americans each year, but a major experiment has shown that ordinary aspirin might save some of those lives. The experimenters recruited more than 20,000 doctors who were randomly divided into two groups. Half received the treatment, an aspirin tablet every other day. The other half took a placebo, an inert pill disguised to look like aspirin.
There were 104 total heart attacks in those who were assigned at random to aspirin, and there were 189 heart attacks for those assigned at random to placebo.
That works out to a 45% reduction in heart attacks. The effect was so striking that the experiment was stopped ahead of schedule and its results given national publicity. Millions of potato chips, each the same as the one before, or at least that's the manufacturer's goal. How does a company like Frito-Lay maintain consistent standards? From the selection of incoming potatoes through peeling, slicing, frying, and seasoning. Checking every chip is obviously impossible. The solution is to select small batches at random and subject these samples to rigorous tests. In potato chips, computer chips, and just about every other industry, sampling is the foundation of modern quality control.
Is Ohio going to let the pollsters and the pundits decide this?
One of the most common ways to produce data is a poll or survey. We sometimes try to ignore them.
I discount these polls.
But polls are a potent force in modern society. National surveys sample just 1,500 people to assess what 240 million Americans think about politicians, products, and problems.
Do you favor or oppose the death penalty for persons convicted of murder?
I oppose it.
Okay.
Enormous efforts are made to gather statistically reliable data. Interview subjects are randomly selected across the country. The wording of questions is carefully tested, and interviewers are trained to avoid influencing a response.
Then is it okay to probe and say 20 times, 30 times?
You suggest an answer?
Well, is it? No?
No,
okay.
Absolutely. You never suggest an answer.
Polls give us reliable snapshots of public opinion, and when survey information is compiled over many years, we can identify significant trends.
We have this impression that the world is changing wildly around us. Actually, it isn't, but it is changing very steadily.
January 28, 1986. The shuttle is ready for another routine launch. Challenger tragically reminds us of the ever-present risk of space travel.
All operators, contingency procedures in effect. Don't reconfigure your console.
After the accident, NASA re-examined joints in the shuttle's booster rockets. Although each individual joint looked highly reliable, probability calculations showed that 6 joints connected together were much less dependable. In fact, probability analysis was instrumental in the overhaul of the entire shuttle program. In a casino, each roll of the dice, spin of the wheel, and turn of a card is genuinely random. But statistics can predict the precise distribution of outcomes in the long run. That's why an individual gambler can strike it rich or go broke. But the house does a profitable business every day of the year.
You have to quit while you're ahead because that's the only way you'll beat the game. If you keep playing, you win, and you keep playing, and you're a fool.
Finally, statistics helps us to interpret the data we've collected, to draw accurate conclusions, and to measure just how confident we can be about them.
Matt Perez is taking aim against racial discrimination in the FBI. Perez and over 300 Hispanic agents challenged the FBI in a class action lawsuit, charging discrimination in hiring, promotion, and the assignment of law enforcement duties.
People were being put into what we call the taco circuit, meaning the trenches, the work that was not career enhancing.
To argue his case, Perez and his lawyer presented statistics. They showed that the status of Hispanic agents was very unlikely to have arisen by chance alone. Their analysis persuaded the judge, who ruled in favor of Perez and ordered the Bureau to establish new policies to correct the problems.
What you've got to be very careful of, and what, or at least what I look for, are the assumptions that go into the building of this picture that they're trying to paint for you. Because that's what statistics do. They paint a picture for the judge.
The Duracell batteries we make now live longer than the ones from a few years back.
A claim like this has to draw on facts.
Today's Duracell.
And at battery manufacturers like Duracell and Kodak, these facts are conclusions drawn from data. Batteries are randomly selected off the production line, mounted in a rack, and then drained of energy under conditions that mimic real use. Statistics enables the manufacturer to estimate battery lifetime very precisely.
This population of AA batteries, when used in a toy, can be considered to last 7.5 hours plus or minus 20 minutes, and our confidence in that range is 95%. Our management can go ahead and make decisions based on that confidence level.
Shall I die? Shall I fly?
Did Shakespeare really write this poem? Why were people tried and hanged as witches in colonial Salem? Statistics is helping scholars in literature, history, and other areas of the humanities to solve mysteries like these. Historians have discovered that in the 17th century, accused witches lived on one side of Salem, their accusers on the other. This geographic division is too sharp to attribute to chance alone, so statistics supports a verdict of political persecution. The vocabulary used in Shakespeare's known works was compared to this recently discovered but disputed manuscript, and statisticians concluded that Shakespeare could indeed have written the poem.
What we could have hoped for, perhaps, was that such a bad poem would have been clearly non-Shakespearean, in which case we could have disproven the Shakespeare hypothesis. But like a paternity test, it can only rule out, it can't rule in.
Originally designed to help, welfare has become a trap for millions of women.
I walked around depressed all the time. I mean, really, you run out of food, you know, I mean, it's terrible.
But an experiment in Baltimore showed that welfare could be improved. A group of welfare recipients was divided in half. One half went through the existing program. The other half participated in a new program called Options. At Options, the women received remedial education classes, counseling, daycare, and job training.
$5.50. No, that's incorrect.
The result? Women who went through the Options program found more jobs and received better pay than women in the existing program. Congress drew on these conclusions in new legislation to reform the welfare system.
So there you have it, the big picture of what statistics is all about. Making the best use of information you have, gathering information you don't have, and drawing reliable conclusions. Whether you're a student who needs to learn how to solve problems, or a concerned citizen who wants to make more informed judgments about public issues, or a savvy consumer who insists on weighing evidence for yourself, the science of statistics is a powerful and durable tool for success.